Picture this. Jupiter looks like a calm, colorful giant until you get close and realize the paint is moving and the planet is a living monster. Subscribe, because what Juno just found down there makes the old textbooks look like a bedtime story. Tonight, we're gonna do this the right way, slow, clear, and a little spooky. We'll use what NASA's Juno mission actually measured, why some of it still doesn't make sense, and why the newest data doesn't make Jupiter feel safer. It makes it feel less stable. And near the end, I'm going to explain the one discovery that changes how we should think about Jupiter forever, because it's not just weather, it's the planet's body moving. Now, let's start with the lie we all grew up with. Most of us were taught Jupiter is basically a big, boring ball of gas. Pretty stripes, a famous red storm, a big gravity shield that catches asteroids so Earth doesn't get hit as much. The solar system's bouncer at the club. That story is not totally wrong, but it's the kids' version. The real version is Jupiter is a giant engine, a deep, grinding machine made of gas turning into liquid, liquid turning into metal, and metal making magnetic forces so violent they can cook a spacecraft if you get too close. And NASA did get too close. That's why Juno matters. For decades, we played it safe. Voyager flew by. Galileo orbited, but it still had to treat Jupiter like a danger zone. Cassini and New Horizons waved as they passed. Because Jupiter's radiation belts are not a joke. They're like a giant invisible electric trap wrapped around the planet. If you've ever put a phone too close to a strong magnet and watched it glitch, now imagine that magnet is the size of a planet, and it's also throwing charged particles at you like a sandblaster. So when NASA and the engineers at places like JPL and their partners built Juno, they built it like it was going to war. Juno's brain isn't sitting in a normal metal box. It's locked inside a thick titanium vault. Not because it looks cool, because Jupiter would fry its electronics like popcorn without it. And instead of doing the easy thing and staying far away, Juno does these wild dive bomb passes. It comes screaming over Jupiter's poles, drops down close to the cloud tops, grabs a burst of data, and then runs away again before the radiation can stack up too much damage. That's why people call it a suicide mission. Not because NASA wanted it to die fast, because Jupiter is the kind of place where too many close looks can kill you. And Juno didn't do it once. It kept doing it, again and again. More than 50 deep passes, and every time it survived, it sent back data that made scientists sound like they were trying not to shout on live TV. Because the first terrifying truth is simple. Jupiter doesn't have a real surface. On Earth, you can fall through clouds and eventually hit ground, ocean, land, something solid. Even if you have a very bad day, you stop falling. On Jupiter, you don't stop. If you fell into Jupiter, you'd start in those bright white ammonia clouds, freezing cold, around minus 150 degrees Celsius up there. So cold, your bones would complain if you even had bones. Then you go deeper, and the air gets thicker. The pressure climbs. The cold turns into heat, and the air stops acting like normal air. This is the part that messes with people's heads, because your brain wants a clean picture. Gas up top, liquid ocean maybe, solid core at the bottom. Jupiter doesn't care what your brain wants. Down deep, the hydrogen gets squeezed so hard it stops being a normal gas. It turns into a strange state where it's kind of like a liquid, kind of like a gas, and it doesn't behave the way you expect. And deeper still, the hydrogen becomes something that sounds fake, even though it's real. Liquid metallic hydrogen. Think about that phrase for a second. Liquid, metallic, hydrogen. Hydrogen on Earth is a gas that can fill a balloon. On Jupiter, the pressure crushes it into a dense ocean that conducts electricity like metal. So when people say Jupiter is a gas giant, it's like calling the ocean a wet puddle. Technically true, but you're missing the point. Jupiter is a planet-sized machine with layers that blur into each other, gas turning into fluid, fluid turning into metal, while the whole thing spins insanely fast. And that metallic layer is not just a cool science fact. It's the reason Jupiter is dangerous in a way Earth isn't, because that layer is part of what powers Jupiter's magnetic field. And Jupiter's magnetic field is a monster. Here's a way to picture it without making it complicated. Earth's magnetic field is like a shield bubble. It's strong enough to guide compasses, make auroras, and protect us from some of the solar wind. Jupiter's magnetic field is like that shield bubble on steroids holding a chainsaw. It's massive, it's intense, and it creates radiation zones that don't just annoy spacecraft, those zones damage them. So Juno flies like a thief. In fast, grab what you can, out fast. Now, Juno has a bunch of instruments, but two matter a lot for the creepy stuff. One is the microwave instrument that can sort of see below the cloud tops. Not like a camera, more like it can read what's happening under the visible skin. Another is the gravity and magnetic measurements, because gravity tells you how mass is arranged inside the planet, and magnetism tells you where that electric engine is working. And when Juno started reading Jupiter properly, the planet basically said, "Oh, you thought I was simple." Let's talk about storms, because storms are the first thing everybody imagines with Jupiter. You know, the great red spot, the big red eye, the ancient hurricane bigger than Earth. But that's the famous celebrity storm. Juno showed us the ugly backstage. The first nightmare discovery was lightning that shouldn't exist. On Earth, lightning comes from water clouds. You get water droplets, ice, collisions, electric charge separation, boom. On Jupiter, Juno saw lightning higher up than it should be if it worked like Earth, way up where it's too cold for liquid water to behave normally. So scientists had to ask a question that sounds like a joke until you realize it isn't. What if Jupiter has storms that make ammonia hail? And then the answer turned into something even weirder. NASA researchers started describing these things called mushballs. I know, it sounds like a snack. It is not a snack. A mushball is basically a toxic slushy hailstone. Water mixed with ammonia, like an antifreeze cocktail from hell. Ammonia can keep water from freezing the normal way. So you get this nasty semi-liquid slush forming inside storms, then freezing on the outside, staying mushy inside, and falling like a heavy icy rock. Now imagine billions of these forming during big storm events. They fall down through the atmosphere for a long time. They drag ammonia from higher layers down into deeper layers. Meaning Jupiter's atmosphere is not just wind, it's a chemical conveyor belt. The planet is basically throwing toxic snowballs at its own insides. And Juno's data suggests this isn't rare. This is part of how Jupiter works. So now you've got a planet with no surface, crushing pressure, weird fluid states, and storms that produce ammonia, slush, hail that can fall for hundreds of miles. That alone would be enough for most planets to earn a villain role. But Jupiter isn't done. Because the stripes, the famous pretty stripes you can see with a backyard telescope, those aren't just skin deep either. For a long time, astronomers argued about how deep the jet streams go. Are those belts and zones just a shallow weather layer, like Earth's clouds? Juno weighed the winds using gravity measurements. And what it found was basically, these winds are deep, really deep. Not a few miles, not a few dozen miles. Think thousands of kilometers deep. So instead of Jupiter being a calm ball with a thin layer of weather on top, Jupiter is built out of moving wind systems that are part of the planet's structure. Like the planet is made of spinning layers that slide past each other. If you could touch Jupiter, don't, please. You wouldn't feel a surface. You'd feel a giant rotating system of currents and shear forces. And when huge layers of a planet are sliding past each other, you get friction. And when you get friction in something that big, you get energy. And when energy builds up in fluid, you get storms that don't behave like Earth storms. This is where Jupiter stops feeling like a bigger Earth and starts feeling like something else entirely. Now let's go to the poles, because this is where Juno delivered one of the most unsettling images in planetary science. People expected the poles to look messy, like boiling soup. That's what fluids do when you spin them. Chaos. Swirls everywhere. Instead, Jupiter's poles showed something almost designed. A huge cyclone in the center, and surrounding it, a ring of other cyclones arranged in a near perfect shape like a polygon made of storms. At one pole, it looks like a storm pattern that keeps its spacing, like gears that refuse to merge. And on Earth, storms merge. Hurricanes interact. They eat each other. They weaken. They combine. Jupiter's polar storms can sit there like a pack of wolves in formation. That's not normal weather. That's a stable pattern in a violent fluid system. And stable patterns usually mean one thing. Something deep is controlling the motion. This is where a lot of scientists start pointing at Jupiter's magnetic field again, because magnetism and deep flow are tied together when you're talking about conducting fluids like metallic hydrogen. So when you hear a perfect storm polygon, don't just think cool picture. Think, what force is strong enough to keep storms trapped in place on a planet made of moving fluid? Now, I'm going to slow down because we're about to step into the part of the story where Jupiter stops being mysterious and becomes honestly unsettling. The biggest question Juno was built to answer was simple. What's inside Jupiter? We had this clean picture for years. Outer atmosphere, deeper layers. Then, at the center, a solid core rock and ice like the pit of a fruit. Juno's gravity data didn't match that clean picture, not even close. It pointed to a core that isn't a neat, solid ball. Instead, scientists started using words like diluted and fuzzy. Here's the simplest way to picture it. Imagine you expect Jupiter's core to be a hard, dense stone in the middle. Juno suggests it's more like someone smashed that stone into dust and mixed it into the surrounding layers. So instead of core then gas, it's like core stuff smeared outward. A messy soup of heavier material blended into metallic hydrogen. And that is not a small detail. If Jupiter's core is fuzzy, something violent probably happened early in its life, something that disrupted how the planet settled. One idea that keeps showing up in the science conversation is an ancient impact. A young Jupiter colliding with a large protoplanet early on, a cosmic car crash. And if you're hearing that and thinking, okay, but that was billions of years ago, hold that thought. Because if Jupiter's insides are still not settled neatly, that suggests the planet's deep structure can stay weird for an unbelievably long time. Meaning, Jupiter isn't just a stable shield for Earth. It's a giant that may still carry scars from its birth, and those scars shape its storms, its magnetic chaos, and its radiation violence today. Now, before we go deeper into the magnetic weirdness, because yes, it gets worse, we need to talk about the thing people underestimate most about Jupiter. It's loud. Not loud like you can hear it through space, but loud in radio waves. Jupiter produces strong radio emissions. Scientists have studied these for decades, from ground observatories and space probes. This is where you can naturally tie in older listening concepts like the long history of radio astronomy, and yes, even the legacy of big radio facilities like Arecibo's past data being used for all kinds of sky studies. And the reason Jupiter is radio loud is the same reason it's dangerous. Charged particles plus magnetic fields plus motion equals energy. A lot of energy. Now add Jupiter's moons into it, especially Io. Io is the volcanic one. It dumps material into space. That material gets caught in Jupiter's magnetic field, gets turned into plasma, and gets forced along magnetic paths. So Jupiter isn't just a planet with weather. It's a planet with an electrical system, a planet-scale dynamo. And when Juno flew through Jupiter's environment and measured it up close, the story stopped being pretty stripes and started being, this planet is running a power plant in the dark. Juno's first magnetic readings looked wrong. The planet's field wasn't symmetrical. It had bruises. A normal magnetic field has a north pole and a south pole, clean lines like a bar magnet. Jupiter's looked fractured. One of the anomalies stood out so much, scientists gave it a name: the Great Blue Spot. It isn't an actual blue cloud. It's an area where the magnetic field punches outward, near the equator, like a second south pole. Juno's magnetometers, built and calibrated at NASA's Jet Propulsion Laboratory and the Harvard-Smithsonian Center for Astrophysics, mapped it in detail, and every orbit showed it drifting east, a magnetic pole, moving fast, being torn by the winds above a metallic ocean thousands of kilometers deep. That means Jupiter's dynamo, the layer of liquid metallic hydrogen generating the field, isn't fixed. It's fluid and unstable. When a field this strong shifts, everything tethered to it shifts too. Radiation belts twist, plasma trapped around the planet gets flung outward. The entire magnetosphere pulses like a heartbeat. Voyager 1 and 2 caught hints of this decades ago when their instruments registered sudden magnetic flips, but Juno finally confirmed the pattern. Jupiter's heartbeat isn't steady, it's spasmodic. Above those shifting fields lies one of the strangest sights in the solar system, the auroras. On Earth, they're gentle curtains of light caused by the solar wind. On Jupiter, they're engines of violence. The European Space Agency's XMM Newton telescope, along with data from NASA's Chandra X-ray Observatory, recorded X-ray bursts from Jupiter's poles every 27 minutes. Juno matched them with internal plasma surges. And then came Io, the moon that refuses to rest. It spews a ton of volcanic gas every second, and Jupiter's magnetic field grabs it, ionizes it, and stretches it into an invisible donut, the Io plasma torus wrapped around the planet. A filament of that plasma connects Io directly to Jupiter's poles. Think of it as a permanent lightning bolt, millions of amps strong, a current that never switches off. That current drives the auroras. It creates a hiss in radio frequencies, literally the sound of electricity screaming across space. Decades ago, the old Arecibo dish picked up similar emissions. Juno's instruments recorded them again, clearer than ever. The planet hums like a broken power transformer. Now imagine all of that energy pouring back into Jupiter's atmosphere. It doesn't just glow, it cooks. The upper layers heat unevenly, driving more turbulence, feeding the deep belts and zones below. Jupiter is a feedback loop. Magnetic energy stirs winds, winds distort the magnetic field, the distortion creates new bursts of energy. A self-feeding storm system the size of a miniature sun. That's why Juno's engineers talk about weather made of electricity. It isn't poetry, it's literal plasma physics. The European Southern Observatory's spectrographs confirmed emission lines from charged hydrogen and helium rising far above the visible clouds, proof the planet's magnetism and its weather are physically linked. And yet, under all this chaos, Jupiter maintains patterns, those perfect polygonal storms at the poles, the steady belts around the equator, the rotating cylinders deeper down, order inside madness. It's as if the planet's internal currents keep rewriting the laws of fluid dynamics, just enough to stay alive. That brings us back to the Great Red Spot, the ancient storm we thought would outlive us. Juno's microwave radiometer measured its roots extending more than 200 miles deep. It isn't just a cloud pattern, it's a vertical structure, a column pulling heat upward from the metallic hydrogen layer itself. But the storm is shrinking. The Hubble Space Telescope's long-term imaging shows its diameter has dropped by almost half in a century. The winds are tightening, the color is fading, and scientists at the University of California, Berkeley now suspect the storm is bleeding energy into the deeper layers that Juno mapped. That's the irony. The deeper we look, the more alive the planet seems and the faster its visible face is dying. Now here's the part that makes the new data feel worse. Because once you accept that Jupiter isn't a calm gas ball, you start noticing a pattern in everything Juno keeps sending back. Every time we look deeper, the planet gets less simple. The first simple idea we all grew up with was Jupiter is mostly hydrogen and helium. It's smooth inside, the storms are just skin deep, and the magnetic field comes from one clean, stable engine far below. Juno basically walked into that classroom, grabbed the chalk, snapped it in half, and said no. And the reason it can do that is because it doesn't just take pretty pictures. It carries instruments that act like X-ray vision for a planet. The microwave radiometer on Juno doesn't care what the clouds look like. It listens to microwave signals coming from below the cloud tops, and those signals change depending on temperature and what gases are in the way, especially ammonia and water. In plain language, it can smell where the weather is coming from. And what it smelled was uneven, weirdly uneven. Jupiter's ammonia isn't nicely mixed like a well-stirred soup. It's patchy, streaky, and sometimes it forms deep columns that go down and down. So those stripes you see from Earth aren't just pretty bands painted on top. They're connected to real deep circulation, like the planet has internal conveyor belts that don't match our tidy diagrams. That's why the mushball story hits harder than people realize. Because mushballs aren't just a fun word, they're a mechanism. They're a conveyor belt made of toxic slush that drags chemicals from the upper atmosphere down into places we can't see. So imagine you're a scientist trying to answer a basic question like, how much water does Jupiter have? You would think that would be straightforward. Scan the gases, measure water vapor, do some math. But if ammonia and water are getting packaged into these falling sludge hail missiles, and if storms are constantly hiding and re-hiding that chemistry, your measurement becomes slippery. Literally. It's like trying to measure how much sugar is in a cup of tea while someone keeps dropping sugar cubes into a drain at the bottom and then stirring the whole cup with a blender. That's why the new data can feel worse. Not because it's bad data, because it's good data that shows the problem is more complicated than we wanted. And then Juno does something even more rude. It flies over the poles again. And those perfect shaped storm patterns are still there. Think about that. On Earth, if you had 8 hurricanes arranged like a perfect ring around a central hurricane, meteorologists would lose sleep because you'd immediately ask, what is forcing that pattern to stay? Jupiter's polar cyclones don't just exist. They hold formation. They drift, they jostle, but they don't just smash into one megastorm like you'd expect. That tells you there's a rule in Jupiter's atmosphere that we don't fully understand yet. Something about rotation, heat flow, and the planet's shape that corrals storms into lanes. And that's where the word worse makes sense. Because the old story was, Jupiter is chaotic weather on the outside, simple physics on the inside. The new story is, Jupiter is chaotic weather on the outside and hidden rules on the inside. And the two are connected. Now let's talk about the magnetic field again, because this is where Jupiter starts feeling less like a planet and more like a living machine with a wiring problem. Juno's magnetometer mapped Jupiter's field in crazy detail, not just strong, not just big, but lumpy. Like a magnet that got dropped, cracked, and glued back together wrong. And that great blue spot idea, this concentrated region of magnetic intensity, matters because it doesn't behave like a quiet, stable bar magnet. Juno's measurements showed the field changing over time in a way that suggests the dynamo region isn't locked deep in the center the way Earth's is. The action is closer to the surface than we expected inside that metallic hydrogen layer. Meaning the engine room is nearer to the walls where the weather can mess with it. So you've got deep winds. You've got a metallic ocean conducting electricity. You've got a magnetic field that's not symmetrical. And now the planet's own flow can literally tug on its own magnetic features. That's not a neat, finished story. That's an ongoing fight. And it connects to something people love to ignore because it's invisible: radiation. Jupiter's radiation belts aren't a side note. They're one of the main reasons this mission is so intense. Juno is armored, yes, but even armor doesn't make you immortal. Radiation slowly degrades instruments, messes with electronics, adds noise, forces teams to work around glitches. NASA engineers and scientists at places like JPL and the Juno team's home base at Southwest Research Institute have had to keep the spacecraft alive through an environment that is basically a particle storm. It's one reason those close passes feel like death dives, because they are. So every time Juno dives, it's a trade. Get closer equals get better data, but also burn more lifetime. And because of that trade, there's pressure, not panic pressure. More like you're standing in a museum with a flashlight that only has 10% battery left, and the door is going to lock soon, and you just found a whole new hallway you didn't know existed. What do you look at first? The Great Red Spot? Europa's surface? Io's volcano plumbing? The deep ammonia patterns? The poles? The magnetic anomalies? This is why the new data is worse. The planet isn't giving one clean answer. It's handing you 10 doors at once. Now let's zoom out for a second and talk about the original myth you mentioned. Jupiter as Earth's bodyguard. Yes, Jupiter's gravity can deflect or capture some objects, but it can also do the opposite. It can reshape the solar system's traffic. Jupiter is like the biggest bouncer in the club, except sometimes the bouncer throws people into the crowd. It can sling comets. It can disturb asteroid families. It can kick objects into new orbits. That's why some scientists talk about Jupiter not just as a shield, but as an architect of chaos. And Juno's work ties into that, because understanding Jupiter's interior and gravity field isn't just planet trivia. It feeds models of how the solar system formed. If Jupiter's core is diluted, if it's mixed out instead of being a clean rock ball, that's a clue to its birth story. It hints at violent formation, early collisions, and a messy growth phase where Jupiter may have swallowed huge bodies. That's the planet-eating vibe your script captured. And it's not just drama, it's one of the serious hypotheses. A major impact early in Jupiter's life could mix heavy elements upward and leave a fuzzy, spread out core instead of a neat one. Now here's the emotional gut punch moment. We're not just learning what Jupiter is. We're learning what kind of solar system we live in. A solar system where the largest planet may have been built through violence, where moons get cooked and cracked by tidal forces, where radiation is strong enough to sterilize surfaces, and where oceans might still hide under ice because a giant monster planet keeps squeezing them like a stress toy. That's the twist. Jupiter is terrifying. And also, it might be the reason some worlds stay warm enough for chemistry to keep going. Europa is the obvious example. Tidal heating. An ocean under ice. Chemistry on the surface altered by radiation. Then mixed downward by cracks and chaos terrain over time. And NASA treating Europa like a priority, Europa Clipper. Huge attention from scientists at NASA centers and universities worldwide isn't random. It's because Jupiter's worst data points to something bigger. The outer solar system is not dead, it's active. And once you accept that, you start seeing Jupiter as the center of a whole kingdom of weirdness. Volcano world, feeding plasma into space. Europa, ocean world, hiding its secrets. Ganymede, the only moon with its own magnetic field, meaning it has its own little mini bubble inside Jupiter's monster bubble. Callisto, ancient, cratered, possibly layered interiors. Juno wasn't originally meant to be a moon mission, but the mission evolved, and those close flybys, especially of Europa and Io, turned Juno into a scout for the next era. And here's where I want to slow the pace down again, because this part is important for your title. The new data is worse. The worst part isn't the storms. It isn't the lightning. It isn't even the idea that Jupiter ate a planet. The worst part is this. Juno is showing us that even the biggest things we thought we understood, like a giant planet's interior, can still surprise us when we finally dare to look closely. We've been staring at Jupiter for centuries with telescopes. We've flown past with Voyager. We've orbited with Galileo. We've watched it in infrared from observatories on Earth and from space telescopes. And yet, one spacecraft flying close over the poles made us rewrite the story. So if Jupiter fooled us for that long, what else have we been calling understood? Just because it looked pretty from far away. And that is exactly why the Juno mission matters beyond Jupiter. Because the techniques Juno uses, gravity mapping, microwave sounding, magnetic field mapping, are the same kinds of tools we'll need when we study giant exoplanets around other stars. This connects straight to places like the Harvard-Smithsonian Center for Astrophysics, where people model how planetary systems form, and to future observatories like the Vera Rubin Observatory that will flood astronomy with new discoveries, forcing us to stop relying on old, simple stories. It's Soba. Jupiter is basically our local training ground for the galaxy. And the planet is not training us gently. It's training us like a coach who throws you into deep water and yells, "Swim." One more thing before we roll forward, because you mentioned you want the parts to flow without that okay, next feeling. There's a strange quietness underneath all this violence. Juno's best discoveries didn't happen in fireworks. They happened in patterns. A repeating pulse, a storm formation that holds, a magnetic anomaly that drifts, a chemistry cycle that keeps moving material up and down. Jupiter isn't random chaos. It's structured chaos. And structured chaos is scarier because it means the monster has habits. And here's the part that makes Jupiter feel less like a planet and more like a working machine that doesn't quite work right anymore. Because Juno didn't just see weird clouds. It measured Jupiter's insides by watching how Jupiter tugs on the spacecraft. Think about that for a second. Juno can't drill into Jupiter. It can't land. It can't drop a probe and call you back later. The planet would crush and cook anything like a soda can in a furnace. So Juno does the next best thing. It lets Jupiter's gravity pull on it, and it reads that pull like a fingerprint. When those gravity readings came back, scientists expected a neat story. A heavy core at the center, layers on top, a clean boundary, like a peach. Skin, fruit, pit, but the data didn't give a pit. It gave something messy. They call it a dilute core, which is a polite way of saying the middle of Jupiter looks like it was blended. Instead of a tight ball of rock and ice sitting cleanly in the center, the heavy stuff seems smeared out, mixed into the deeper layers. Like somebody took the core and stirred it into the planet. That's not how a calm, stable gas giant is supposed to look. So the question becomes simple and ugly. What could stir a planet? And that's where the cosmic car crash idea comes in. One leading explanation is that early Jupiter got hit by something big, not a pebble, not a normal asteroid, something closer to a young planet. And if a big body slammed into a baby Jupiter at just the wrong time, it could have shattered the original core and mixed everything together. So when you hear new data is worse, this is part of what that means. Not worse like we're doomed tomorrow, but worse like the old clean textbook picture is dead. Now let's layer that with something even stranger, because Jupiter's magnetic field is also acting like it has a problem. Most people imagine a magnetic field like a bar magnet. Simple, one north, one south. Nice and tidy. Jupiter is not tidy. Juno mapped Jupiter's magnetic field up close and found a region so intense and weird that it got a nickname, the Great Blue Spot. It's basically a magnetic bruise, a concentrated patch of crazy strong magnetic energy near the equator that doesn't fit the simple bar magnet vibe at all. And here's the unsettling part. It looks like the winds are stretching and distorting it over time, like taffy being pulled in two directions. That alone tells you something important. The deep interior is not just sitting there like a quiet engine. It's flowing, shifting, and dragging the magnetic field around. So now you've got two big warnings from Juno. 1, the core is not clean. 2, the magnet is not behaving like a normal, stable planet magnet. And then Jupiter does the third thing. The thing that sounds like science fiction, but it's not. It flashes X-rays from its poles on a timer. Every 27 minutes, like a heartbeat. For decades, scientists saw Jupiter's X-ray aurora and basically said, okay, but why is it pulsing like that? Because on Earth, auroras don't pulse like clockwork. They dance, they drift, they change with the solar wind. Jupiter's is different. NASA-linked teams use data from Juno and X-ray telescopes like Chandra, and they finally nailed down a strong explanation. Waves and processes in Jupiter's huge magnetic environment can set up conditions where charged particles get funneled into the atmosphere in a repeating rhythm like the planet is ringing like a bell, and the poles are where the sound comes out as light. The end result is this eerie, regular X-ray flicker that makes Jupiter feel less like weather and more like circuitry. And now the scary part becomes emotional, not just scientific. Because when you stack all of this together, the mushballs, the deep jet streams, the geometric polar cyclones, the broken-looking magnetic field, the pulsing X-ray aurora, the diluted core, you stop seeing Jupiter as a big, safe shield. You start seeing Jupiter as a violent, complicated system that's still dealing with old trauma from the early solar system. It's like meeting someone who looks calm in a photo, and then you spend 1 hour with them and realize they're running on pure chaos and caffeine. Now, let's talk about why NASA sounds nervous sometimes when this gets explained to the public. Because Jupiter has two faces. The face you see through a backyard telescope is pretty. Bands, colors, the red spot. It looks like art. But the face Juno sees is physics with teeth. And NASA can't just say Jupiter is a monster in a press release. They have to say it in careful, boring words like complex dynamics, and unexpected interior structure. They talk like that because the real message is heavy. Jupiter is not finished. Jupiter is active. Jupiter is still rewriting what we thought a gas giant is. And Juno is running out of time. This is the part that hits me every time. The reason Juno has an ending at all isn't because the team got bored. It's because of planetary protection. Juno has been flying through the Jupiter system long enough that one day something could go wrong, a small failure, a small drift, and it could accidentally crash into a moon like Europa. And Europa is one of the places where we think liquid water might exist under the ice. So NASA can't take chances. When the mission ends, the plan is for Juno to plunge into Jupiter so it doesn't contaminate anything else. So the closer Juno gets to the end of its life, the more intense these final passes become. Every dive is like, how much can we learn before the vault finally loses the fight? And that's why the new data feels worse. Not because it's fake, not because NASA is hiding aliens in Jupiter's clouds. It feels worse because every new answer is also a new crack in the old picture. And once you see those cracks, you can't unsee them. So here's the big question we have to sit with as we keep going. If Jupiter's interior is mixed up like this, and its magnetic field is getting tugged and stretched by deep winds, and the polar storms are holding their shapes like they're locked in place, what is Jupiter going to look like in the long run? Not next week, not next year, but over decades? Because if the Great Red Spot can shrink within human history, if magnetic features can drift, if the planet's deep structure is still settling from an ancient impact, then Jupiter isn't a background object in the solar system. It's a living system, a giant one, and it's closer to still happening than we like to admit. Remember how I said Juno does those polar death dives? That isn't just for drama, it's survival. Jupiter's radiation belts are no joke. They're packed with charged particles whipped up by Jupiter's insane magnetic field. If you fly through the wrong place for too long, your spacecraft electronics don't get stressed, they get cooked. That's why Juno's brain is literally hidden inside a titanium vault, and why its orbit is designed like a hit and run. In Measure Like Crazy, then Get Out. NASA has explained this as part of the mission's whole strategy: get the data without getting your robot killed early. And when Juno started mapping the magnetic field properly, the protective king story started falling apart. Because Jupiter's magnetic field isn't just strong, it's messy. You know how a fridge magnet has a clean north and south? Jupiter doesn't behave that clean. Juno's data shows weird concentrated patches of magnetism, including that famous intense region people nicknamed the Great Blue Spot. What makes that unsettling isn't just that it exists, it's that it appears to change and drift over time, like the planet's hidden metal ocean is sliding around under the skin and dragging the magnetism with it. NASA has described Jupiter's magnetic field as surprisingly complex, and later analysis found signs of time variation in parts of the field. So now imagine what that implies. If the magnetic field is being generated by liquid metallic hydrogen deep down this weird state of matter that acts like an electrical conductor, then the field is basically a live readout of what the interior is doing. And Juno is telling us the interior isn't calm. It's moving in ways that make scientists uncomfortable, because it means Jupiter's engine room may be more active and more uneven than the neat textbook diagrams ever admitted. Now let's go even higher above the clouds into the part of Jupiter that doesn't just glow. It pulses. Jupiter's auroras are not like Earth's gentle northern lights. They're massive, violent, and tied into a whole electrical system that connects Jupiter to its moons, especially Io. But the really creepy part is this. Astronomers using NASA's Chandra X-ray Observatory and ESA's XMM Newton found that Jupiter's X-ray auroras can pulse on a roughly 27-minute rhythm, like a heartbeat, like a timer. And no, that does not mean aliens. It means something in Jupiter's magnetosphere is acting like a resonating instrument waves in plasma, magnetic field lines ringing like a giant cosmic guitar string. The problem is, when you hear a planet sending X-ray pulses every 27 minutes, your brain does what brains do. It tries to turn it into a message. It isn't a message. It's worse. It's a symptom of a system so big and powerful that it can literally run its own repeating energy cycle bright enough for X-ray telescopes to notice from Earth orbit. Now, let's drop back down into the clouds, because this is where the new data is worse line really earns its keep. For years, people looked at Jupiter's bands and storms and assumed most of the action was shallow, like a thin weather layer on top of a simple ball. Juno basically said, nope, the weather is part of the body. One of the freakiest examples is the ammonia mystery. Juno saw that ammonia isn't evenly mixed. Some regions are depleted, some are rich, and the patterns don't behave like simple air mixing. That's where the mushball idea comes in, the concept that violent storms can create slushy ammonia water hail that falls deep and drags ammonia downward, changing the chemistry higher up. NASA scientists describe this as a possible explanation for why Jupiter's atmosphere can look patchy and wrong in ammonia distribution. So when you picture Jupiter as a calm painting and then you step closer and realize the paint is moving, this is literally what's happening. The color is chemistry, and the chemistry is being hauled around by storms so deep they're basically geological events. And then there are the polar cyclones. This part still messes with people because it looks designed, even though it's not. Juno saw that Jupiter's poles aren't a random swirl. They're organized, a central cyclone with others arranged around it in a stable pattern. NASA, JPL briefings, and mission materials describe these polygon-like arrangements, storms packed together like gears, holding formation instead of merging the way you'd expect on Earth. That stability is what makes it eerie. On Earth, storms fight, merge, fall apart. On Jupiter, some of these monster storms can stay locked in place because the whole planet is a rotating fluid machine with different layers sliding against each other. And the Coriolis forces are extreme. It's physics, but it feels like architecture. Now let's talk about the inside again, because this is where the story stops being just cool weather and becomes Jupiter's history is violent. Juno's gravity measurements push scientists toward the idea that Jupiter doesn't have a neat, compact core like a tidy peach pit. Instead, evidence points toward a dilute or fuzzy core region, heavy elements spread out and mixed into the interior over a big fraction of the planet's radius. In plain language, the center looks stirred, not stacked. And once you accept that, one scary explanation starts sounding logical. A colossal impact early in Jupiter's life. Not a little rock, something protoplanet-sized, enough to smash, mix, and permanently mess up the interior structure, leaving Jupiter with a blended, diluted core instead of a clean one. That idea has shown up in university-led modeling discussions around Jupiter's interior mixing and formation pathways. So Jupiter may not just be big because it collected gas. It may be big because it won a food fight in the early solar system. And if that's true, then the protector of Earth reputation becomes complicated. Because yes, Jupiter's gravity can deflect comets and shape orbits, but Jupiter also throws things around. It can fling objects inward, outward, sideways. It's less like a security guard and more like a bouncer in a crowded club. Sometimes it kicks trouble out, sometimes it starts the trouble. And here's the part people don't say out loud often enough. The reason Jupiter is so important is because it's basically the solar system's memory. Its chemistry, its core structure, its storms, its moons, everything about it is a fossil record of how the whole neighborhood formed. That's why NASA centers like JPL and teams across universities and institutes obsess over it. That's why ESA is sending JUICE to the Jupiter system. That's why NASA is sending Europa Clipper. Juno didn't finish the story. Juno ripped open the cover and showed us the first pages were written in violence. And the new data is worse in the best way because it keeps forcing one conclusion. Jupiter isn't a simple gas ball with pretty stripes. It's a living engine, a planet-scale experiment in pressure, electricity, chaos, and time. And we still haven't gotten to the part where Jupiter's weirdness spills into the moons in ways that might rewrite what we think habitable even means. Because Europa isn't just an ice moon anymore when your parent planet is blasting. It, with radiation, flexing it like a stress ball, and possibly feeding it chemistry from above. Hold that thought, because the next layer of this story isn't inside Jupiter. It's around Jupiter. It's the moons. It's the electrical current systems. It's the radiation environment. And it's the reason spacecraft engineers get nervous just saying the words close flyby. If you want to understand why the new Juno data feels worse, you have to stop thinking of Jupiter like a planet you could land on and start thinking of it like a moving engine you can't turn off. Because Juno didn't just take pretty pictures. A lot of what it saw wasn't even made for human eyes. One of Juno's most powerful tricks is that it can sort of listen to Jupiter by measuring tiny changes in gravity as it flies over different regions. Imagine you're driving fast over a bridge and you feel a tiny pull to the left, then a tiny pull to the right. If you're sensitive enough, those little tugs tell you where the heavy parts are underneath. Juno does that, but on a planet scale. And when Juno did that, it told us something that should not be comfortable. Jupiter is not neatly layered. We used to talk about Jupiter like a clean diagram. Clouds, gas, metallic hydrogen, then a solid core, sitting there like a stone in the middle. But gravity data says the core is smeared out, diluted, fuzzy, not a tight ball, more like someone blended it halfway into the planet. That matters, because it changes the story of how Jupiter became Jupiter. A clean core suggests calm growth. Dust becomes rocks. Rocks become a core, and then gas piles on top. Simple. A diluted core suggests violence, mixing, stirring, impact, chaos. Something big enough to mess up the inside of a world the size of 1,000 Earth. And here's where the new data is worse feeling kicks in. Because once you accept that Jupiter's insides are mixed up, you start looking at everything else differently. The belts and zones, the stripes, stop being weather. They start looking like the outside skin of a deep, rotating machine. And the poles? The poles are the part that makes scientists go quiet for a second, because it looks like nature accidentally built a design. On the Juno mission page, NASA literally shows that the polar cyclones are arranged in a pattern. A monster storm at the center, with a ring of storms around it, almost like a crown. On Earth, storms bump into each other and merge. They break apart. They die. On Jupiter, these things have been holding formation for years. That's not a windy day. That's stability coming from deep physics rotation, heat flow, maybe magnetic effects, maybe the way energy rises from the interior. And now we get to the part most people don't realize. Juno didn't only show us Jupiter's face. It showed us the supply chain of Jupiter's chaos. Those mush balls you described, that's not just a creepy fun fact. It's a clue that Jupiter's atmosphere is constantly being robbed and reloaded like a conveyor belt. The Mission Juno team, run through Southwest Research Institute, describes mushballs as slushy hail, water, and ammonia mixing in storms, forming heavy clumps that fall, dragging ammonia downward. And researchers tie major ammonia depletion patterns to powerful storms and deep convection, which is basically the planet turning parts of its own atmosphere inside out. So when you look at Jupiter and see pretty stripes, what you're really seeing is the top of an active system that moves chemicals up and down and dumps them into deeper layers where we can't watch directly. That's why Jupiter starts feeling like a monster that eats itself. Not because it has teeth, but because it recycles its own body over and over at pressures and temperatures that don't exist on Earth in nature. Now let's talk about the part that really earns the word worse. Their passive magnetism. Jupiter's magnetic field is so strong and so weird that it doesn't behave like the clean classroom magnets people picture in their head. And its auroras? They don't just glow, they pulse. Some studies using X-ray observations have measured auroral pulsations with timescales in the tens of minutes range around to 25 minutes reported in some work, and other observations have found shorter rhythms too, depending on what's driving the system that day. That's important because it means Jupiter isn't only reacting to the sun like Earth does. Jupiter has its own internal power grid. It's like the planet has a heartbeat that sometimes syncs to the solar wind and sometimes doesn't. And once you bring Io into the story, this moon that constantly dumps material into Jupiter's magnetic environment, the whole system becomes a loop. Moon feeds magnetosphere, magnetosphere feeds aurora, aurora feeds energy back into the atmosphere. And that brings us to the part viewers always feel but can't name. Jupiter isn't just a planet, it's a system that acts alive. Not living like a creature, but living like a storm that never ends. Now, quick reality check, because this matters for your credibility on YouTube. People online love to say NASA is hiding the truth, but the real story is usually simpler and more unsettling. NASA isn't hiding it. The truth is just not easy to show in one clean photo. A lot of Juno's worst discoveries are not a single image. They're patterns in data. They're gravity numbers, microwave readings, magnetic maps, long-term changes. That's why if you make your thumbnail only Jupiter but orange, it'll look boring. Your visual has to communicate something else. Structure, motion, pattern, threat, not fake aliens, not cheap horror filters. The feeling that something enormous is running in the background and we only just noticed. And that's exactly where we keep going. Because once you understand Jupiter as a machine, one question gets scary in a smart way. If Jupiter's interior is mixed, and its storms form stable shapes, and its magnetic system pulses like a clock, what else have we been calling normal just because we didn't have the tools to see it properly? And if Jupiter is this extreme here, right next door, what does that say about the countless Jupiter-sized planets we've found around other stars? The ones astronomers study with big observatories and spectroscopy, trying to guess what they're like from tiny dips of light? Jupiter stops being a planet fact. It becomes the key for reading the rest of the galaxy. And here's the part that makes the whole Jupiter story feel personal, not just space trivia. Because Juno didn't just reveal scary features. It revealed a scary rule. Jupiter hides the real action under a thin layer of pretty. So when people say, why doesn't NASA just show us the real thing? The honest answer is, the real thing is mostly invisible. You don't photograph it, you measure it. Juno carries instruments that are basically super senses. One of them is the microwave radiometer. Think of it like a heat vision ear that can hear through the clouds by reading microwave signals coming from deeper layers. It doesn't see Jupiter like your eyes do. It reads the planet's insides in slices. And what those slices suggest is this. A lot of Jupiter's weather is not a skin. It's not a surface effect. It has roots, deep roots. So when you're watching the great red spot from Earth and it looks like a painted red eye, Juno is asking a different question. How deep does that monster go? And when Juno scanned it, the answer wasn't a little swirl. It was more like deep enough to be its own engine. That matters because it tells you the great red spot isn't just drifting on top of the planet like a leaf on a pond. It's tapping into heat and motion from far below. Now combine that with what you already know. The spot is changing, shrinking, tightening, shedding pieces sometimes, like it's losing skin. So the scary thought is not Jupiter has a big storm. The scary thought is, if a storm that deep can weaken, what else on Jupiter can change fast when we assume it's permanent? And that pulls you into the next layer, Jupiter's wind system. For centuries, astronomers looked at Jupiter's stripes and assumed they were shallow, because that's how our brains work. We see a pattern, we assume it's paint on the surface. But Jupiter doesn't do surface. Juno's gravity measurements and deep sensing suggest these jet streams run way down, like massive rotating tubes stacked around the planet. And once you accept that, you start realizing something. Jupiter isn't weather on a planet. Jupiter is a planet made of weather. That's why the word worse fits, because it means the chaos isn't sitting on top of something stable. The chaos is the structure. Now, take a breath, because this is where the story gets even stranger in a quiet way. Those perfect cyclone patterns at the poles, they're not just cool shapes. They're evidence that Jupiter has invisible rules that keep storms trapped in formation. On Earth, if you tried to keep 8 hurricanes in a clean ring, they'd bump, merge, fall apart, and the whole thing would turn into a mess. On Jupiter, the ring holds. So something is balancing them, like a tug of war between the planet's rotation, the flow of heat from below, and the way storms push and pull each other. And here's what makes that unsettling. If Jupiter can organize storms like that, it means Jupiter can store order inside chaos. It means the planet isn't random noise. It's a machine with habits. Now, let's connect that straight into the magnetism again, because this is where the machine starts to feel angry. Jupiter's magnetic field doesn't just sit there like a shield. It interacts with the atmosphere and the moons, and it creates energy events that are not gentle. Auroras on Earth are mostly a reaction to the solar wind. On Jupiter, auroras are also fed by its own system, especially the material coming from Io. So when you hear Jupiter's auroras pulse, don't picture a pretty light show. Picture a giant engine revving on a timer. And that timer is a clue, because rhythmic pulses mean there's a repeating process, a cycle of energy building up, releasing, and resetting. That is the exact kind of thing scientists chase. Because if you can understand the rhythm, you can reverse engineer the machine. But right now, the rhythm raises questions faster than it answers them. Is the pulse mostly controlled by the solar wind? Is it controlled by wave patterns in the magnetosphere? Is it controlled by Jupiter's rotation? Is it controlled by the Io plasma environment feeding the whole system? And this is where your video gets strong. Because you can be honest without killing the suspense. We have real data. We have real measurements. But Jupiter is so extreme that every answer creates two new questions. Now, let's zoom out for a second, because the title of your video says, "The new data is worse," and you want that to land. Here's the simple way to make it land. We used to think Jupiter was a big gas ball with storms. Now we know Jupiter is a layered electric ocean with deep winds, organized polar storm systems, chemical hail cycles, and a magnetic engine that can act like a pulsing lighthouse. That's not worse like a scary movie. That's worse. Like, the reality is more intense than the old textbook picture. And here's the last piece. You need to push the tension forward without rushing. Juno is not alone anymore. NASA's Europa Clipper is on the way to focus on Europa. And ESA's JUICE mission is also headed to the Jupiter system to study Jupiter and the icy moons. So the story is about to stop being Juno's weird discoveries. It's about to become a full investigation of the Jupiter system as a living neighborhood, Jupiter as the engine and the moons as the things caught in its power. And that brings us to the most uncomfortable question of all. If Jupiter can reshape the chemistry of Europa's surface with radiation, if it can heat Io into non-stop volcanoes, if it can run a magnetic system like a power plant, then Jupiter isn't just protecting Earth from asteroids. Jupiter is shaping what life could look like in this part of the solar system, not by kindness, by force. And once you see that, the planet stops being a peaceful giant in a painting. It becomes a moving monster that creates and destroys at the same time. You can feel it now, right? The moment where this stops being cool Jupiter facts and starts being a problem. Because the deeper Juno goes, the more Jupiter looks less like a planet and more like a living engine that never turns off. And then comes the pass that makes the room go quiet. Not because the images are pretty, because the numbers don't make sense unless something is happening inside Jupiter that we did not expect. Juno swings in on another death dive. The spacecraft is moving so fast, it's basically skimming a world that could swallow it whole. And as it passes, the instruments don't just read clouds, they read mass. They read force. They read the way Jupiter's gravity and magnetism tug at the craft, like invisible hands. And that is when the worst part hits. Because the data says Jupiter's interior is not behaving like a clean, stable, layered planet. The core is not a neat, hard ball sitting calmly in the center like we taught in school. It's smeared, mixed, diluted, like somebody kicked the foundation of the planet and left it permanently unsettled. And once you accept that, suddenly the surface makes more sense in a terrifying way. Those deep jet streams aren't just winds. They're part of the planet's body. They are rotating cylinders of motion that dig thousands of kilometers down, like the planet is built out of moving parts. Those perfect polar storm shapes aren't just weird weather. They look like the result of a system that's being guided by rotation, by deep heat, by forces we can't see, like the planet has invisible rails under the clouds. The Great Blue Spot isn't just a funny magnet map. It's evidence the magnetic engine itself is getting tugged and stretched by the deep winds. Like Jupiter's dynamo is not locked in place. Like the thing generating the field is closer to the surface than we assumed, and it can shift. And then the auroras, the part that sounds beautiful until you remember what it really means. Jupiter isn't just glowing, it's firing. A pulse, again and again, like a lighthouse that doesn't warn ships. It warns the whole solar system that something down there is dumping energy into space on a schedule. At that point, Jupiter protects Earth starts sounding like the kind of story you tell yourself to feel safe. Because Juno's data is basically saying this: Jupiter is not a quiet shield. Jupiter is an active machine that can rewrite its own rules. And here is the scariest thought in this whole video, the one that sits in your stomach if you let it. If Jupiter can change from the inside, then everything around it lives under the mood of that change. Io's volcanoes, Europa's cracked ice, the radiation that cooks surfaces, the electrical connection between moon and planet, the plasma donuts circling Jupiter like a charged trap. That's not a planet with moons. That's a system, a violent system. And Juno didn't just show us the monster. It showed us the monster has a heartbeat. So now we have to ask the question NASA can't dodge anymore, not if we keep sending spacecraft into that neighborhood. What happens when the engine shifts? What happens if the magnetic weirdness keeps drifting? What happens if the Great Red Spot finally collapses? What happens if those polar storm rings break? Because on a planet like Jupiter, when something breaks, it doesn't break gently. It breaks big, and that's why the new data is worse. Not because it's scary like a horror movie, but because it removes the comfort of the old picture. It takes Jupiter from a big gas ball with storms and turns it into a planet-sized electric ocean with deep moving parts. And you can't unsee that. So when you look at Jupiter now through a telescope and you see the stripes and the red spot and the calm painted beauty, just remember what Juno taught us. That calm look is a mask. Under it, the paint is moving. Under it, the colors are screaming, and the giant is still awake. If you want, I can keep going deeper on the exact Juno flybys that revealed these discoveries and the next wave of missions, Europa Clipper and ESA's JUICE. Because the truth is, Juno was only the opening act. Subscribe, because the next data dumps are going to make this story even stranger.